on to our next system property, which is causality. So we want to look at causal and non-causal systems. So we'd like to determine if a system is causal, memoryless, anti-causal, or none of the above. So system H is causal if the output at time t or time n, if we're talking about discrete time signals, only depends on the input at times smaller than or equal to t. So basically, if it depends on the current or past, that's a causal system. The system is anti-causal if it depends on the current or future. So if it depends on times greater than equal to t or greater than equal to n, the output at time t or at n. And the system is memoryless. It's a special case of causal and anti-causal. It only depends on the current time. So a system, for example, that the output only depends on the current input, that's a memoryless system. And a system which doesn't satisfy any of these, this is a system which is neither causal nor anti-causal in this language. So we can see this in pictures. So memoryless systems have outputs that depend on the current input. So this t only depends on this value right here of the signal. So this is the signal x of t. A causal system only depends on the magenta curve, so this curve over here. So causal systems only depend on the current and past inputs, and the anti-causal systems depend on the current and future inputs, so all of this green curve here. So let's do a couple of examples. So again, script H is our notation for a system. So let's look at the integrator. The integrator is a system which integrates the signal x of t from minus infinity up to time t. So it takes integral of minus infinity to t, x of tau d tau. This is a causal system because the integral goes over the past. So the taus, that is the times at yt, say at 5 seconds, it only depends on values of x of t before and up to 5 seconds. I have to fix a little typo here. So in the next example, y of n is equal to x of n cosine 5 pi n. This system is memoryless because the output at time n only depends on the input at time n. That is, y of n only depends on x of n. The cosine is beside the point. We're looking at how the output depends on the input signal. Our third example, y of t is equal to x of t plus 2, x of t plus 2. This is actually an anti-causal system because the output at time t depends on the input at time t plus 2 and also the input at time t. So it depends on the current and a future input. So that's an anti-causal system. What about x of n is equal to x of minus n, the time reversal system? Well, this is actually neither causal nor anti-causal. If I look at positive times, the output depends only on negative times, so that's causal. But if I look at negative times, the output depends on the future, depends on positive times. So this system is neither causal nor anti-causal. Sometimes for some values of n it looks causal, and some values of n it looks anti-causal. So overall, can't really say anything. So try it out yourself. For these systems listed below, try to determine if it's causal, memoryless, anti-causal, or neither causal nor anti-causal. It is useful to kind of go through this process because it helps you get a feel for what this causality property really means. It's sometimes a little tricky the first time you look at it, so it's important to do these examples.